Hello friends, welcome to Just 32. This is last part of module 2, that is part 3. Uh, Today we will study about interrupt structure and power saving mode of 8051. So let's get started. In interrupt structure of 8051, there are two SFRs, that is I and IP. These two SFRs are controlled. These two SFRs gives the control to interrupt structure of 8051. I stands for interrupt enable register. This is used to enable a particular interrupt. Now, as we have studied, there are total 6 interrupts in microcontroller 8051, which of 2 are external and 4 are internal. Now, let's see here. X stands for external and T stands for timer. X stands for external, T stands for timer, and S stands for serial. Now there are 2x, 2t and 1s, which gives you count of 5. Now as we have discussed, there should be 6 interrupts. So why there are only 5 enable inputs, not 6? Now in as we have studied, there are two serial interrupts, that is TI and RI. Now they are combined in ES, that is serial enable. So why they are done something like that, even though they have this free space? So there is a reason behind that. The both interrupts started from 00 to 3H vector location. So as they are starting from the same vector location, so that means the at a time only one can be occurred, that is the transmission interrupt or a receiving interrupt. So rather than giving them TI and RI enable, they have just combined them in the ES, that is serial interrupt. And apart from this, if you want to control them as a single global bit, then we have this EA enable. If we set this 0, then boom, all are gone. Nothing it matters if you set this all are 1 or 0. If this bit is 0, then all are 0. No interrupt will occur. That is, all are maskable, therefore they all will be masked. So now, if in a particular situation you want to give a certain interrupt more priority to other, then for that matter we need a priority register, that is interrupt priority register. Now you can see they are like this only, so there is nothing um, big something. They are just relevant. Here is PS stand for priority for serial interrupt, PT1 stands for priority for timer 1 interrupt, and PX1 stand for priority for external 1 interrupt, that is INT 1 bar. This is simple. We'll see the structure. Now here you can see this is for that interrupt is a level or triggered. Now don't be confused with this I and this I. This is not a enable, this is an enable register. So this I is from TCON. From last video we have seen that I bar is set when interrupt is coming, and no next interrupt will come on INT 0 bar until we will clear this I0 from the TCON. Same for the INT 1 bar, and as we have seen that the ES, that is RI and TI, are combined over here, that is ES. Now in I register we have this individual bit for all, that is EX, that EX0, EX1, ET0, ET1 and ES over here. if we set the EA to 1, then this will be considered. If we have set this to 1 or 0, this according to this which will work. They are all maskable, so you can mask them with this all. Now if this is not set, then doesn't matter, that is global enable and individual interrupt enable. You have to draw the same diagram over the paper exam. Then we have IP register, that is priority register. According to the priority, this is a high priority block and this is a low priority block. uh, if two interrupts come, one with high priority and one with low priority, then high priority interrupt will be served first than the low priority interrupt. Now if two interrupts with same priority, that is high priority or low priority, will come, they will be served according to the internal polling sequence, that is from upward to downward, as you can see over here. So this is all about interrupt structure. It is very easy, there is nothing difficult and confusing. Now I'll see about power saving mode. In serial mode, I've shown you this same register that for this, that S mode is used for uh, set the baud rate for serial communication by timer 1. And then I now this is mainly for power control and it is used in power saving mode or power control of the 8051. These are general purpose flag bits, and this is to actually control those two bits are actually used to control uh, the power savings or the power control of 8051. This you can manipulate those bits the way you want. You can manipulate the way the restriction or the uh, according to the requirements of the system. So why they have given the power saving mode is main reason because of the that the microcontroller, the embedded system mainly used with the batteries. For certain time, if the battery is going low, then you can stop the some working of the microcontroller 8051 to save the battery, so that the system will run as long as possible. And we'll see the main about this PD and ideal. This is a powered on mode and one is ideal mode. Now this will clear, you will clear with this diagram. Now if you set the ideal bar from that PCON, then this NAND gate won't um, allow power supply for the CPU of 8051 microcontroller, and but the clocks will be provided to this other parts of microcontroller, that is timer counter, serial port, interrupt structure and all this. The contents of CPU, that is A register, B register, stack pointer, all will be stored and will not get affected as long as power is supplied to the microcontroller. Um, Now if you go into the ideal mode or power ideal mode, then one of the bit, that is GF1 or GF2, will be set uh, according to the program. Then in power down mode, if you set this power down mode, and here it will come the oscillator is connected to the this. Now if you connect if you set the PD, that is power down mode, then the power the clocks will not be given to the microcontroller. This is also known as freeze state, in which microcontroller won't do anything, but the contents of the register and SFRs will be set, and they will contain those as long as power is supplied to the microcontroller 8051. Now, to come out of this ideal mode or power down mode uh, are different. In ideal mode, you can be come out of the ideal mode by software or hardware reset. If you by any enabled, as we've seen that enabled interrupts, any one enabled interrupt can change this value of ideal, and the CPU will start working, or by resetting the microcontroller will also start the CPU. There are two methods by which you can come out of the ideal mode, but in power down mode there is nothing working actually in the microcontroller, so that you can't come out of the power down mode by internal or by software means. You have to come out of the power down mode by reset input given to the uh, microcontroller. So all register will set to 0 zeros, and SFR will contain the default value, and microcontroller will start executing from 000H. So this is how the power control or power saving mode of 8051 works. So with this we are done with the module 2. Hope you understand something out of it. Thank you.